Hi, and welcome to Conquer the Concept. In this video, we're going to learn how to solve questions 20 to 25 from the 2019 AMC 8 competition. Let's start with question 20. How many different real numbers x satisfy the equation x squared minus 5 whole square is equal to 16? Let's start by rewriting the equation. X squared minus 5 whole square is equal to 16. This is an algebraic equation that we need to solve. We can first start by removing this square. Square root on both sides to get x squared minus 5 is equal to plus or minus 4. It is plus or minus 4 because 4 times 4 is equal to 16, but negative 4 times negative 4 also equals 16. This can be broken down into two separate equations. X squared minus 5 is equal to positive 4, and x squared minus 5 is equal to negative 4. When we add 5 to both sides, x squared becomes 9, and when we square root, x is equal to plus or minus 3, because 3 times 3 is equal to 9, and negative 3 times negative 3 also equals 9. Let's add 5 on both sides here, which becomes x squared is equal to 1. Square root on both sides to get rid of the square, and this becomes x is equal to plus or minus 1. 1 times 1 is equal to 1. Negative 1 times negative 1 is also equal to 1. Here, we have four unique solutions. Positive 1, negative 3, positive 1, negative 1, positive 3, and negative 3. So we get D is equal to, it is D, four unique solutions. Now, let's go on to question 21. What is the area of the triangle formed by the lines y equals 5, y is equal to 1 plus x, and y is equal to 1 minus x? This can be solved by drawing a graph. Okay, graph. It doesn't need to be exact. So then we can start by marking in 5 interval points. Okay, so let's start by graphing y equals 5. Y equals 5 is a horizontal line which has a y-intercept of 5. Next, we can graph y is equal to 1 plus x. Y is equal to 1 plus x has a y-intercept of positive 1 and has a slope of 1, which means it goes up 1 to the right 1, up 1 to the right 1. And this is an approximation of that line. Next, we can graph y is equal to 1 minus x. Y is equal to 1 minus x has the same y-intercept as y is equal to 1 plus x, except that it is reflected over the y-axis because it has a negative slope. So this goes up 1 to the left 1, up 1 to the left 1. And this is drawn like that. So we are asked to find the area of this triangle. There are two pieces of information we need to find the area of this triangle. They are the base and the height. The base and the height. In order to find the base of the triangle, we need to find the x-coordinate of this point and the x-coordinate of this point. And then we subtract them to find the length of the base. So in order to find the x-coordinate of this point, we need to find the point in which y equals 5 and y is equal to 1 minus x intersect. So in order to find this x-coordinate, we set y here equal to 5. So 5 is equal to 1 minus x. This gets x is equal to negative 4. Now we do the same, except that we set 5 equal to y here and 1 plus x. 5 is equal to 1 plus x, and then x is equal to 4. So this x-coordinate, the x-coordinate is 4. When we subtract negative 4 and 4, we get that the length of the base is 8. Now we need to find the length of the height. We know that from here to here, it has a length of 1, because this is the y-intercept in this line, and this line is equal to 1. And we know the length from the origin to the y-intercept of the y equals 5 line is 5, because it has a y-intercept of 5. So we can subtract 5 minus 1 to find the length of the height, which is 4. So h is equal to 4. In order to find the area of a triangle, we do half BH. So half of 8 times 4, which is 32, is 16. Let's go on to question 22. A store increased the original price of a shirt by a certain percent and then decreased the new price by the same amount. Given that the resulting price was 84% of the original price, by what percent was the price increased and decreased? Okay, so we can call the price that the shirt was increased and decreased X dollars. We can write an equation to solve this. Let's call 1 the whole price plus X amount of dollars times the whole price minus X amount of dollars, and this is equal to 0.84, which is 84% as a decimal. This seems in the form of A plus B times A minus B is equal to A square minus B square. So to put this in the form of A square minus B square, you do 1 square, which is just 1, minus X square, which is X square. And this is equal to 0.84. We can subtract 1 from both sides, and this becomes minus X squared is equal to negative 0.16. And then we can cancel the negatives on both sides. X squared is equal to 0.16. We can square root on both sides, and we get that X is equal to 0.4. 0.4 expressed as a percentage is 40%. And this is our answer, E40. Now, let's go on to question 23. After Euclid High School's last basketball game, it was determined that 1/4 of the team's points were scored by Alexa and 2/7 were scored by Brittany. Chesley scored 15 points. None of the other seven team members scored more than 2 points. What was the total amount of points scored by the other 7 team members? Okay, so in order to find the fraction of the points scored by Alexa and Brittany together, we can add their fractions. So 1/4 plus 2/7 is equal to, set a common denominator of 28, and this becomes 7 plus 8, and this is equal to 15 over 28. So if Chelsea scored 15 points, then 15 plus 15 equals to 30, but that's more than the total amount of points scored by the team. So we can increase this by a scale factor. So if the scale factor is 2, then this fraction is equal to 30 over 56. Because it'll be times 2 times 2. Now, if we add 15 to this total, which is the amount of Chelsea's points, this is equal to 45 over 56. Now, we see that 11 points are remaining. And this is the points that will be scored by the other team members on Alexa, Brittany's, and Chelsea's team. So our answer is B11. Let's look at question 24. In triangle ABC, point D divides line AC so that AD to DC is 1 to 2. Let E be the midpoint of the intersection of line BC and line AE. Given that the area of ABC is 360, what is the area of triangle EBF? So we are asked to find the area of this triangle. Okay. So, in order to do this, we can make the entire figure composed of triangles. We see that this figure, and this figure are all triangles, but this figure is not. So we can draw a line here to make it so that the whole figure is composed entirely of triangles. Okay, so now we can find the area of each specific triangle. Since we know that these two, AD to DC is in the ratio of 1 to 2, we know that the area of ABD to DBC is equal to 1 to 2. And since the entire area of ABC is 360, we know that the area of ABD is 120 and the area of DBC is 240, because 120 times 2 is equal to 240. Therefore, they're in the ratio of 1 to 2. We also know that BE is congruent to ED. Therefore, the area of triangle ABE is equal to the area of the triangle AED. So ABE is equal to ADE. So since the total area of the triangle ABD is equal to 120, we divide by 2 to find the area of each triangle. So each one is 60. So we have 60, 60. Now we can find the area of EDC easily. Since AD to DC is in the ratio of 1 to 2, the ratio of AED to EDC will be in the ratio of 1 to 2 as well. So 60 times 2 is 120. So the area of EDC is 120. When we add all these values up, we know that the area of BEC, when we add these values up, it is 240. 360 is the area of the entire triangle, so it means BEC is equal to 120. So we can call the area for a targeted triangle X, then that means this one will be 120 minus X. We can solve a simple proportion to solve this now. So X over 60, which is its respective triangle vertically, is equal to 120 minus X over 180. So we see that this is 3 times. Okay, so 3x is equal to 120 minus x. So we add x, 4x is equal to 120, and then x is equal to 30. So this is our answer, B, 30. Now, let's go on to solving question 25. Alice has 24 apples. In how many ways can she share them with Becky and Chris so that each of the people has at least 2 apples? So let's start off with Alice having 2 apples, Becky having 2 apples, and Chris having 2 apples. And this is the worst case scenario because each of them must have at least 2 apples. However, this is 6 apples altogether, and there are still 18 apples remaining. In order to solve this problem, we can use a concept called stars and bars. So what is this exactly? If we have an n number of objects, in our case it is 18 apples, we use a number of bars to separate them, and we want 3 groups, A, B, and C. So the number of bars we will use is 3 minus 1, which is 2. So if we use 1 bar here, 1 bar here, then we have 1 group, 2 groups, and 3 groups. Okay, so in order to solve this problem, we need to use this formula. The number of objects plus the number of groups minus 1. Choose the number of groups. Choose number of groups. In our case, this is equal to the number of objects, 18, plus the number of groups, A, B, and C, which is 3, minus 1, over 3 minus 1, which is 2. This becomes 20 choose 2. 20 choose 2 is the same. 20 choose 2 is the same thing as just doing 20 times 19 over 2. And this is just equal to 190. And that is our answer. C, 190. Thank you for watching this video, and don't forget to subscribe and like to conquer the concept.